Hey everybody, this is Alex Merced, and you are listening to Data Nation, where I like to talk about data topics. And today I want to talk about the term directed acyclic graph. Okay, um, and we're sort of like, what does that term mean? Okay, I mean it's a fancy word; it means something quite simple. Um, but generally, this is used. DAGs are used to kind of help orchestrate your data pipelines. Okay, so the idea is that basically you need to get data from point A to point B, but along the way, there's a lot of things you got to do with the data before it actually lands in point B. And some of those things may have to happen at the same time. Some, it's not necessarily just, hey, do one, do two, do three, do four. It's not a straight line. It's not, and it doesn't necessarily repeat. Okay, so this is where we start getting into these words. Directed. So directed means it's going. So if you were to imagine like point A and point B, you're starting from the left and moving towards the right. So it's directed. You're moving in a particular direction. You're not going backwards. Acyclic meaning it doesn't cycle. Okay, so it's a graph, but never does it go. Never do any of the nodes in this graph. Okay, so when you move from one point in the graph to the next point in the graph, never do you end up going backwards. Okay, so it's never going to repeat itself. Okay, it's acyclic. It's not cyclical. It doesn't go back and end up backward started like a circle. Okay, a circle is cyclical. It cycles. Okay, and it's a graph. Okay, so basically it's a bunch of nodes, okay, connected by edges. So it's a directed acyclic graph. But essentially you have your starting point, okay, and the idea is that each node represents a task that needs to be done to get to where you are going. Okay, so essentially you might have three different things that need to be done, or you might have multiple things you need to be done with the data. Okay, three of them don't affect each other. So essentially, like you do A, B, and C, you could do them. You could apply them to the data at the same time, and they're not going to affect each other. Okay, so in that case, you're better off doing them at the same time because then you can save time if you have three different processes going at the same time, making these transformations to the data. Okay, or it just you might be working on some other data set that's needed for a later part of the transformation. Okay, so you might create three branches. Okay, so imagine like you have your starting point, and then you have three edges coming from that with three dots, and those three jobs can happen at the same time. Okay, because they don't affect each other necessarily, depending on what they're doing. But all three of them have to be done before D happens. Okay, so then you take that graph, you see like you have that starting node, it branches off into three branches that hit those three nodes that are happening parallel to each other, but then all three of those need to be done, and then D happens. So then you see those three branches all basically uniting once again in D. Okay, but you see like it's not. But essentially, when you think of that visual, you can kind of imagine sort of the way things need to happen. You know what depends on what, so you know that D depends on A, B, and C, but A, B, and C don't depend on each other, so they can happen at the same time, but D has to wait for A, B, and C to be done. Okay, and that's essentially all it is. It's just basically saying, hey, these are all the things that need to happen, and well, this thing depends on these things, so that way it knows what order it should do things, so that way you can have a bunch of different processes going on at the same time without any process starting before its dependent processes have completed. Okay, and you can use tools like Astronomer, Dagster, whatnot to create these DAGs, and essentially they're orchestrating jobs with all your favorite tools. I mean, they could be sending queries to Dremio, sending queries to Spark, Flink, whatever. But their job is just to kind of orchestrate in what order all these things happen among all these different tools. Okay. Yeah. Okay. So hopefully that helps you understand what is a DAG. Okay, a direct acyclic graph, and what its purpose is. It's not as crazy as it sounds when you first hear it. But again, DAG is just the structure of data, but again applied to here trying to schedule sort of tasks that depend on other tasks to get to a final point. Okay, so my name is Alex Merced. I'll see y'all later. Again, follow me on Twitter at AMDataLakehouse. Have a great day and enjoy.